All right, in this video, we're going to take a look at conditional probability using a two-way table. And what we're going to look at is actually the COVID-19 test and some information we have about one of the COVID-19 tests, the CELEX one specifically. So we have two percentages to the right here. Our first one is sensitivity, 93.8%. What that means is that is the percent of sick people that are correctly identified as having COVID-19, so correctly identifying that they are sick. We also have 95.6% specificity. That's just the percent of healthy people that are correctly identified as not sick. So healthy people who don't have COVID-19 and they're correctly identified as not having it. And then we don't know the actual percentage, the prevalence of COVID-19, but right now we're just going to assume a 1% prevalence. So assume about 1% of the population has it. First, people are either going to be infected or not infected. So people will either have COVID-19 or not have COVID-19. So the actual reality of if they're sick or not sick. And then on the left here, we have the test results. So the test is either going to find that they are positive, that they are sick, or negative, they are not sick. So infected versus test results. What we can do is think about a population, think about a number to make these percentages a little bit more concrete. Let's look at a population of 100,000 people. So maybe like a smaller city. So out of 100,000 people, if 1% have the virus, that means that we have 1,000 people who are actually infected and 99,000 people who are not infected. So I'm just putting down the totals of these two rows down here, total and total. 1,000, 99,000. If we have a 93.8% sensitivity, so the number of sick people over here who are correctly identified as sick, right here, 93.8% of that 1,000 people means that we're going to have 938 people who are sick and are correctly identified as sick. For specificity, we're looking at the not sick people, the healthy people, that 99,000. And we're looking at the test correctly identifying that these people are not sick. And that percentage, 95.6%, tells us that 95.6% of 99,000 is 94,644. So that's the number of people who are healthy and who the test points out are healthy, correctly identifies. Now we're going to look at two other numbers. And these numbers are when the test goes wrong. So the first one down here is something we call a false negative. And a false negative happens when someone is sick, but the test incorrectly identifies that they are healthy. So it gives them a negative result, but that result is actually false. It's not true. And a false negative happens, well, if it correctly identifies it 93.8% of the time, a false negative is going to happen 100 minus that, so 6.2% of the time. We're going to have a false negative, 6.2%. So 6.2% of 1,000 gives us 62 people. So 62 of the sick people are going to take the test in this case and be told that they are healthy. The other box that we're going to look at is called a false positive. And this is a situation where someone is healthy, but the test incorrectly says that that person is actually sick. So these are healthy people that are told that they are sick or were sick. And some of these people might assume they were asymptomatic. So they were sick, but they didn't feel any symptoms. This percentage is going to be 100 minus the 95.6%. In other words, we have a 4.4% false positive rate. which gives us 4,356 healthy people who are told that they are sick incorrectly. Now we can take a look down the rows and find out the totals down these two rows. Total over here. First, we could look at the total number of people who are told that they have a positive result, so told they are sick. That's going to be 938 plus 4,356. So we have a total of 5,294 down this row. So we have 5,294 positive test results. Next, we'll look down the bottom row, 62 plus 94,644 gives us 94,706. So of the, and these will both rows and columns add up to our total population, 100,000. Of the 100,000 people, 94,706 of them are going to receive a negative result. 5,294 of them are going to receive a positive result. So we can use these numbers to see the probability, if you get a negative result or a positive result, that the probability that you are in fact sick or not sick. For example, looking at the right, so out of the positive results, we have 4,356 people who are healthy and 938 people who are actually infected or are sick. And what we can see here is that, thinking about conditional probability, if we assume that we get a positive result, one question we could ask is, what is the probability you actually are sick or were sick? And in this case, using our numbers, so here we have 5,294 total. The probability that you were actually sick, so we had 938 sick people out of a total of 5,294, which if we calculate that as a percentage, we end up with 17.7 about %. So what this means is even though our test, it sounds really accurate, if we look at the people who receive positive results, in this case, only 17.7% of them actually are sick. So the vast majority of people who receive positive results for this test are actually healthy, so weren't sick at all. So this happens because if we have such a small prevalence percentage, 1%, because there is such a large number of people who are healthy, even if our tests are very accurate in the 90s percentages, the small percentage of healthy people that are incorrectly identified is still going to be a much larger number than the percentage of sick people, which is quite a lot fewer or smaller, the percentage of sick people that are correctly identified. So in cases like this, with tests like this, even if you're identified as sick, only 17.7% of those identified as sick were actually sick. So the other about 82.3% of people might assume that they were already sick and that they can't catch the virus when in fact they couldn't. So this is an example of how to use a two-way table to look at conditional probabilities. With two-way tables, we'll usually be given these percentages, and then we can fill out the table and look at the results that we get on the right and on the bottom to make conclusions.